Hey guys, welcome to Terraform for Beginners series. Today we are going to explore 6 different Terraform commands along with their practical use cases. So let's get started and let's learn about our first command. So far we have written this code where we are creating an AWS EC2 instance of type T2 Nano and we are naming it test_EC2. Now since this instance hasn't been created yet, and typically, before we create any resources using Terraform, we run the Terraform Plan command to see what Terraform is going to create and with what configurations. Here, it tells us what will be added, what will be changed, and what will be destroyed. But right below this, there is another thing mentioned which you might have noticed at some point. It says, you didn't use the -out option to save this plan. So Terraform can't guarantee to take exactly these actions if you run Terraform Apply now. This means that we haven't used the -out option with the Terraform Plan command to save the plan. As a result, Terraform doesn't ensure that if we use the Terraform Apply command now, it will create the exact same resources for us as shown in the plan. Because right now we can see in the plan the exact things we specified in our Terraform files, our instance name test_EC2 and its type T2 Nano. These are exactly same as we instructed. And now looking at this plan, we will use the Terraform Apply command to create the instance so that it's get created. It's possible that if we take some time before running the Terraform Apply command and during that time someone else comes into the file and change the instance type from T2 Nano to T2 Micro. Now, when we run the Terraform Apply command, we might assume that our instance with T2 Nano will be created. But in the reality, it will create the T2 Micro instance for us. That's why Terraform recommends using the -out option with the Terraform Plan command to save all the plans into a single file. And in the future, whenever we want to run the Terraform Apply command, we should use this file. The plan that tells us what resources will be created at this moment will actually create those same resources when we apply that file. So let's give this option a try. Now, we will run the Terraform Plan -out command followed by a file name. You can choose any name you want for the file where you want to save the plan. For now, I will name the file EC2_plan. EC2_plan will be the file where the entire plan's output will be saved for us. As soon as we run this command, firstly it will show us the complete plan. And after displaying the plan, it will save the entire plan into a specified file. And here, it's letting us know that to apply this file, we will need to run the Terraform Apply command followed by the file name. So our plan file has been created, which contains our configuration with an instance type of T2 Nano. Now, regardless of any changes or addition we make in the actual Terraform file, when we run the Apply command using this saved plan file, Terraform will always create just one instance for us. An instance with the type T2 Nano and the name test_EC2. Alright? So let's go ahead and apply this file and see. To apply the file, we need to run the Terraform Apply command followed by the file name. And this time it won't ask us whether we want to create the resources or not. It will directly start creating the resources for us. So let's allow the apply process to complete. Now our first instance has been created. So this was our first command in which we used the -out option to save our entire plan into a file and then used that file to create our resources using Terraform. Now let's move on to our second command. So let's say we modify the instance type inside this Terraform file from T2 Nano to T2 Micro and save the file. After that, if we run the Terraform Plan command, it will show us that it will change our instance type from T2 nano to T2 micro whenever we run the Terraform Apply command. Alright, now let's go ahead and run the Terraform Apply command once. When we run the Terraform Apply command, it first shows us the entire plan again and highlights the changes that will be made. After that, it will ask us whether we want to apply this plan or not. As we have already seen the plan inside the plan command and we don't want to review the plan again, we want the apply process to complete quickly. For this purpose, we can use the command Terraform Apply -auto approve. By adding the -auto approve option, it won't prompt us with the yes or no question, which usually require us to type yes to confirm. Instead, it will immediately run the apply process without any further interaction. In some cases where you have thoroughly reviewed the output of the Terraform Plan command and you are confident about what Terraform is going to create, you can use the Terraform Apply -auto approve command. This way, you won't have to manually confirm with a yes or no, and the apply process will be completed by Terraform directly. So that was our second command, and now let's move on to our third command. Whenever we write code in the real world, it's crucial to organize our code in a well-structured manner to make it easy for everyone to read. Any team member or anyone else who wants to read the code should not face difficulties in understanding it. As you can see in this code, the indentation is all over the place and it's making it hard to determine where certain elements are located. This lack of code organization makes it quite challenging to comprehend, even though the amount of code here is relatively small, but in the real world or as we teach more complex concepts, the amount of code will increase. And understanding unorganized code become even more difficult. Hence, it's essential to write code in a properly organized manner. For this purpose, Terraform provides a feature or a command called Terraform FMT. When we run the Terraform FMT command, Terraform automatically organizes our code in a structured manner. As you can see, as soon as we run this command, our entire code becomes properly organized with correct indentation. Everything is now in order to make it easy for us to read the code. Therefore, we recommend that after writing our files, we run the Terraform FMT command and then push our code to GitHub. This ensures that our code maintains a proper and easily readable structure. So that was our third command. Now let's move on to our fourth command. Now our instance type in the Terraform file is set to T2 micro. And if we check the state file as well, it will show that our instance type is T2 micro there too. So let's go to the AWS console and manually change the instance type of this instance from T2 micro to T2 small. Once we make this change, our instance type will be updated to T2 small and our instance will be in a running state. Now, if we run the Terraform Refresh command, it will fetch the current state of that instance by querying AWS. This means that any changes that have occurred to our instance outside of Terraform's control will be captured and updated in our state file. As we can see in our current state file, the instance type is still T2 micro. However, once we execute the Terraform Refresh command, it will refresh our state and capture the current changes. So if we check the state file after running the Terraform Refresh command, we will see that the instance type has been updated from T2 micro to T2 small in our current state file as well. So the Terraform Refresh command fetches and captures the changes in the current state of our infrastructures and updates our state file accordingly. Whenever we want to import changes from the current state into our state file, we can use the Terraform Refresh command. That's the purpose of Terraform Refresh command. Now let's move on to our next command, which is Terraform Validate. The Terraform Validate command checks whether the code we have written in our Terraform file is valid in terms of syntax or not. If we run the Terraform Validate command right now, it will tell us that the configuration is valid. It means that our code is syntactically correct. So let's try making a change in this code and intentionally break something and see if the Terraform Validate command can detect it or not. In this code, let's change the spelling of instance type and save the file. Now when we run the Terraform Validate command, it should give us an error message stating unsupported argument. So it has detected the mistake and it's telling us that the argument name instance type is not expected here. Did you mean instance type? In other words, the spelling we have used for instance type is incorrect and it's an unsupported argument for this resource. This is how we can catch mistakes easily using the Terraform Validate command. Now let's try something else. Let's remove the name from here and use var.name instead. var.name means we are taking the value from a variable. We will cover the concept of variables extensively in the next video. It's an important concept in Terraform that you definitely shouldn't miss. Now, we have removed the name here and replaced it with the var.name. It means we want to pick the name from a variable. If we run the Terraform Validate command now, it will give us an error again. Reference to undeclared input variable. This means that we are trying to use a variable's value that we haven't declared yet. And if you look closely, it will even suggesting how to declare the variable and what the syntax should be. So the Terraform Validate command is very useful for syntax checking and to ensure our code is correctly written. It helps us to catch unsupported arguments and undeclared variables, and it is an important tool whenever we are writing code. This way we can easily identify mistakes and ensure our code is valid. Now let's move on to the final command in today's video. Before we learn about the last command, if you haven't already, please consider liking this informative video, sharing it, and subscribing to the DevOps Pro English channel to support us. This helps us to bring regular content for you guys. So please like, share, and subscribe to the channel. As we saw a little while ago, we manually changed the instance type of our instance from T2 micro to T2 small in the AWS console, while our Terraform file still specifies T2 micro as the instance type. This is the common scenario in the real world where many people make manual changes to resources, which could potentially disrupt our running application. In such cases, if you want Terraform to completely destroy and recreate that resource, you can use the Terraform Apply -replace option. The -replace option, as the name suggests, it indicates that you can replace any resource. Terraform will fully destroy the existing resource that's already created and then provision a new one based on the configuration specified in our Terraform file. So let's try this out once. So as of now, the instance type in the console is set to T2 small, but in our Terraform file, it is still T2 micro. Let's go ahead and run the Terraform Apply -replace command. After -replace, you need to specify which instance you want to replace. For example, since we want to replace this AWS web instance, we will write AWS_instance.web. As soon as you run this command, it will show you that there is one resource to be added, 0 to be changed, and 1 to be destroyed. This indicates that something new is going to be added, while something will also be destroyed. If you scroll up a bit, you will see that it's actually replacing the old instance with the new one. You will notice the symbol -/+, which represent destroy and then create replacement. This symbol indicates that something will be destroyed and something will also be created, which is why the symbol is used in this plan. This demonstrates how the -replace option can be used to forcefully recreate a resource based on the configuration in your Terraform file. Let's proceed and accept this plan by typing yes and allowing the apply process to complete. Our apply process has finished, and if we now check our instances in the console, you will see two instances listed. One instance is labeled as terminated and the other one is marked as running. Both instances have the exact same name. One has been terminated while the other is currently running. Using the -replace option, you can replace any resource and effectively delete it and then recreate it using Terraform. So these were the 6 different Terraform commands along with their use cases. You will use these commands in various scenarios according to their specific purposes. Try practicing these concepts by experimenting with them. If you have any doubt, feel free to ask in the comment section. And if you haven't already, please like, share and subscribe to our DevOps Pro English channel to show our support. See you in the next video. Thank you.